Hi, my name is Jesse Fielding. I am an advanced diploma civil engineering student at UNISA. The subject I'm doing is WRM701, and this is my design project. Project overview. We had four demand centers whereby we had to build an Ethernet model using it's a free software, using it to build our own reticulation model, and with that a few parameters were given within the project brief, as I will explain later on more in detail. Thereafter we had to generate gravity mains, graphs, and pumping mains, as well as the components that had as head loss. A brief introduction. As part of the water source resource management course at the University of South Africa, we were tasked with a real-life project for Tshepiso local municipality. The goal is to design a hydraulic infrastructure to supply water to four townships using the Ingangwe River as the source. The project involves setting up extraction works, a treatment facility plant at Sikahilo Hill, a bulk storage reservoir in conjunction with pump distribution, thereafter gravity distribution to the townships or demand centers. We accomplished this through Ethernet, as mentioned earlier. On the next slide, we have our supply network. The layout was given us by the project brief, as well as the related elevations. Our datum is 898, and that is equals to 0. Thereafter, we calculated the different evaluation for each node, and thereafter obviously the demand centers and junction points and any point of interest. The methodology followed. Dissect all information provided to ascertain what is given and what is needed. One should carefully review all the project documents and data to understand the scope and requirements. Identify the current water demand for each of the four townships and any projected growth in demand. Gather data and obviously the time patterns and set those. Understand the infrastructure and align the pumps that must be used to overcome the elevation discrepancy. Determine the size of the bulk storage reservoir and check if the size provided is adequate, as well as determining the number of pump stations required. Calculate the total water demand and the required capacity. Assess if the existing reservoir meets requirements. Determine the number and capacity of pump stations needed for efficient water delivery. Build the supply network using the provided Ethernet software. Input data into Ethernet and define the water network layout. Simulate water flow and pressure to ensure the network meets demand. Optimize the design based on simulation results. Following methodology. Parameters. Verify compliance and if your system is compliant to relevant industry standards. Ensure water quality and hydraulic performance are within acceptable ranges, i.e. velocities may not exceed 1.5 meters per second, head losses may not be greater or more than 10%. Discussions of the results obtained. Here we explain key designs, decisions, and summarize simulation results. and we assess the system as a whole in performance-wise, and we offer recommendations and improvements such as the evaluations of the search or transient analysis. We were also given constraining factors. There were key constraining factors: the demands, the topography, and the initial run must be at 300 millimeters to have the nominal diameter of the pipe, no velocity higher than 1.5 meter per second. The head loss for all components must be less than 10% of the total available head. Deliverables: number of pump stations required, head loss of each component, calculations of the storage capacity of the bulk reservoir, hydraulic profiles for the gravity mains, hydraulic profiles for the pumping mains and pump sizes, evaluation of the need for pressure and surge control. My final pipe diameters are 1,850, 600, 600, 400, 400, 600, 400, and yet another 400. Thank you for your time and attention.